we are asked to integrate this item, this function, and then it's easy for us to find out that natural log e divided by x, that means natural log e minus natural log x. So further simplify, we get 1 minus natural log x dx. Separated to two terms, we have natural log 1 over x, we know how to integrate directly. And also we have 1 over x natural log x dx. If we focus on this part, 1 over x natural log x, it just means that we put it inside and then it's give the natural log x, which is the same as what here. That's why we can integrate it in this format. It becomes natural log x whole thing square and divide by 2 plus c. They say that we have to use the method of substitution explicitly. Basically, this is using substitution method. But to ensure your interest, you better let u equal to natural log x. So we handle the presentation later, and then we focus on our calculation first. This gives you natural log x. We do not need the absolute sign is because x is defined as larger than 0. And then this part. Then we stop our calculation here. We write down consider. That means we focus on parts of it only. We set up the strategy let u equal to natural log x. Then we consider du is 1 over x dx. So 1 over x natural log x dx is equal to, we separate two items first, 1 over x dx one group. So this part is replaced by u. This part is replaced by du. That's why when you integrate it, it's u squared and then 1 over 2. And before we finish, we have to change back u in terms of x. So we have to write 1 over 2 natural log x bracket square plus c, where c is a constant. So to conclude, go back to our original calculation is equal to natural log x and then minus 1 over 2 natural log x squared plus c, where c is a constant. We finish part A, then we focus on part B here. There is a curve, that means this function curve, and then we have to write down the x-intercept. This is just a core math question as x-intercept. Y is equal to 0. So that means 0 is equal to gx, and then we are going to solve what is the x fulfill the requirement. 1 over x equal to 0, this is rejected, impossible. Or natural log e over x equal to 0. Then we e over x is equal to e power 0. E over x is equal to 1, therefore x is equal to e. Therefore, in part B, the x-intercept is just 1, e. You don't need to write down this step in your calculation because they say write down only one answer mark for this. I don't know how is the graph look like, I just randomly draw it. Maybe it's like this. It's really not accurate. It's because it should be tends to infinity when x tends to 0. But anyway, random drawing is good enough for us to understand the situation. They say that there is an area bounded by this curve, the x-axis, together with a straight line, x equal to 1. Beware that we know the x-intercept is e. X equal to 1, then is left hand side. And also another line, x equal to e square. E square is 7 point something, so it is right hand side. X equal to e square here. And then to be honest, I don't know which part is above the ground, which part is below the ground. It's just by guessing. Of course, you can substitute some value like 1.5 to test whether it's above the ground or below the ground. Now, we are finding the area of the region bounded by the curve, bounded by the x-axis, and also bounded by these two lines. So now we have two regions we need to calculate. The first region is this region, and also we have the second region here. I just simply label this region be A1, and then we have another region A2. Consider one by one first. Again, break down your calculations such that every time you just need to handle a small easy part. A1 is equal to the height gx, and when x is between 1 to e. So this is our area of A1. Then we just calculate it. And don't forget that we already have the integrated function from part A. So we just simply use the results, natural log x minus 1 over 2 natural log x whole thing square, and then with the upper bound and lower bound here. So two case, the first case e case minus the one case, natural log e minus 1 over 2 natural log e whole thing square. So the first bracket is 1 minus 1 over 2. The second case is the one case, natural log 1 minus 1 over 2 natural log 1 square. So we have 0 minus 0. Let's give 1 over 2. So this part, the area is 1 over 2. And also the value that we found is positive, which means that our assumption that is above the ground is correct this time. So we don't need to modify it. Now we can work on A2. A2 is talking about the height gx, and then from x equal to e square. We can use the result of part A again, natural log x minus 1 over 2 natural log x whole thing square. This time is e square and e. E square case minus e case. Focus on the first term first. That's why we have 2 and then minus 1 over 2 square. The first term is 0. Then the second part is the same as what we calculate here. Natural log e minus 1 over 2 natural log e whole thing square is equal to 1 minus 1 over 2. So we have negative 1 over 2, which gives you negative 1 over 2. You find a negative value is because the height is below the ground. So that's why if you add them together, they will give you a negative value. We just simply need to absolute it. Every row, then we get positive 1 over 2. Therefore, in B2, our answer, area, is equal to A1 plus A2 equal to 1 over 2, and then plus 1 over 2, we get 1 unit square. Don't forget how you separate your calculation and also the drawing, sketch the graph.